Hello, good afternoon. How, Daniel? Ready to study? That's great. Okay, I've got some answers. Good afternoon, beloved. Good afternoon, Chinny. Good afternoon, Jim. Yesterday's work got it, Vikram. Good afternoon, Kiru. Good afternoon, Sanet. Itungu Sanet. Good afternoon, Peter. Good afternoon, Adnan. Yeah. So you have done yesterday's question. Okay, we'll check it. Okay, so before that, we'll just get into these. We'll get into the prime number concept. Okay. Okay. Have you all done with the prime numbers? Okay. I'm just sharing my screen. Just give me a minute. Good afternoon, Nilofer. Okay. So you're going to tell me the prime numbers one by one, and I'm going to write it. Is that okay? I hope the screen is visible. Oh, so I'll just share it again. Can you see? Okay. So quick revision, complex number are split into real number and imaginary number. And the real numbers are again split into rational and irrational. So irrational number means which doesn't have any proper format as P by Q. Irrational numbers can be written in the format of P by Q. So this would be the example of it. And we have natural number, whole number, integers, decimals, terminating decimal, non-terminating decimal, fraction, improper fraction, proper fraction, mixed fraction. And I would have given you some examples of it. I hope. Now we are going to start with the prime numbers. So yes, these are the real numbers. So prime number Can anyone tell me the first 4 prime numbers? That's between 1 to 10. What are the prime numbers? What are the prime numbers between 1 to 10? 2, 3, 4, 7? No. 2, 3, 5, 7, 11? No. Between 1 to 10. Good, Adnan. Sorry, Adnan. Yeah. 2, 3, 5, 7. Yes. 2, 3, 5, 7. It's okay, Jackson. Right now we are starting. And Peter, 1 is a prime number or not? It's not a prime number. 1 is not a prime number. Good. That's a huge response. Can anyone tell me the reason why it's not a prime number? That's okay, Axmed. Why 1 is not a prime number? Can anyone define it? Why 1 is not a prime number? Everything is divisible by itself, even 2, 3, 5, 7. One has only one factor. Okay, any other answer? Adnan is closer, but I cannot say it is right. Your term is missing. It is divided by itself. No, not exactly. 1 is not a prime number because prime number means it should have exactly two factors. If I say prime number, exactly 2 factors should be there. Prime number means exactly 2 factors, but 1 has only 1 factor. Yes, okay. So 1 has only 1 factor, hence it is not a prime number. Yes, it has exactly 2 factors. Yes, Vivian. Okay, so 1 has only 1 factor, hence it is not a prime number. What is the number 1 called as? 1 is not a prime number, that's fine. I hope the same time 1 is not a composite number also. Okay, 1 is not a prime number, that's fine. 2, to prove. Okay, X1 has only 1 factor and these numbers has 2 factor. So why I told you to write it in this format is it will be easy to remember the values. Got it right? 2 has 2 factors. 3 has 2 factors. 5 has 2 factors. That means 5 is divisible by itself and 1. Okay, 3 has 2 factors, 5, 7. So these numbers are in between 1 to 10. In between 1 to 10. The remaining numbers of it, yes, so these all has 2 factors and one has only 1 factors, more than 1 factor composite number. So 1 to 10 only 2, 3, 4, 5. Now from 11 to 20. Eleven, yes. 13, 17, yes. 1, 13, 17, 19. Now from 21 to 20, 21 to 30. From 21 to 30. 23, 29. Okay, let's hold on here. What is 1 called as? 1 is not a prime number, 1 is not a composite number. What is 1 called as? One is called a unit number. Yes, we can. And it is called unit number. 1 is called as unit number. Okay, fine. 23, 29. So 1, 3, 5, 7, 13, 17, 11, 13, 17, 19. Okay. Next, 31 to 40. What are the prime numbers from 31 to 40? 31, 37. 31 to 37. That was not clear. That's fine. Next. Next, 41, 43, 47. 47, yes. So 47. Any other answers you get from 1 to 50? Yeah, we'll finish from 1 to 50, then we'll go on with the rest. From 1 to 50, any doubts? Check it. 39 is not a prime number because 39 has more than two factors. 39 is divisible by 3. 39 is divisible by 13. Prime number means it has only two factors. That means it will divide by itself with the same number or 1. That is called as prime number. A number which is divisible by itself and 1 is called prime numbers. So from 1 to 100, the important things are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 39 isn't a factor because 39 is divisible by more than one factor. Clear with that? $33 is divisible by 11. It is not a factor. Yes, 37 is a factor. Okay, so 2, 3, 5, 7, 11, 13, 17, 19. I'm just erasing in between. All the numbers would not be divisible by 7. 23, 29, 31, 37, 41, 43, and one more number, 41, 43, and yes, 47. Next, we'll start from yes, I have written. Okay, next 51, 52, 53. 59, yes. Any other number in 50s? 51, no. Check it, Peter. 51, if I divide by 3, yes, I get an answer. So there are already 3 factors. Yes, so 51, no. 53, yes. 59, yes. Okay, 61. Yes, 61. 63 will not come. 67, yes. And next, 71. 73, 79. Is there any other number? Okay. 83. 83, 89. 85, going to the test match and returning. Those things are not counted. Okay. Next, last one, 97. Now I'm telling you the shortcut how to remember it. Yeah, just take a look. I have first four numbers from 1 to 10. Okay, from four numbers from 1 to 10. Second one is again four numbers from 1 to 10. Okay, so from 2 to 10, there are four prime numbers. I'm changing the pin colors. From 11 to 20, four numbers. Okay, next 23, 29, 2, 33, 37, 2, 41, 43, 47. This is 3. See, 4, 4, 2 to 3, 2 to 3, 2, 1, 2, and last is -7. You clear with that prime number? Yes, 97 is the last. So 4, 4, 2 to 3, 2 to 3, 2, 1. Okay. So total number of prime numbers. Total number of prime numbers counted. 4, 4, 2 to 3, 2 to 3, 2, 1. 2 to 3, 3 is here. 2 to 3, 2 to 3, 2, 1. 1 to 10, 4. 11 to 20, 4. 21 to 30, 2. 31 to 40, 2. 41 to 50, 3. Next, 51 to 60, 51 to 60, 51 to 60, 2 to 3, 2 to 3, E, 61 to 70, 3, 2, 2, 3, 2, 1. 90 is for 2. 91 for 100 is 1. Just ensure you read all the prime numbers now. Any doubts still here? Yes, beloved. Any doubts? 91 is not a prime number. 91 is not a prime number. 13 multiplied by 7 is 91. 13 multiplied by 7 is 91. Clear with that? So 91 is not a prime number. Did you get that? Did you get it? Yeah. Okay. Can I clear the frame? Can I clear the frame? If you say yes, we'll go on with the next. Can I clear the frame? Okay. Done. So prime numbers are done. Now I asked you certain things to prepare and come. I hope you have done. Yes. Okay. Okay. You can unmute yourselves. Whomever a call or whomever volunteered, you can try. Who wants to try first to answer to my questions? I want you all to answer to my questions. Okay. I want somebody, you can unmute yourself. I've given the access. So yes, you can unmute yourselves. Okay, fine, no. Thank you. Square number, cube numbers, prime numbers. So this would be the question. Nobody is unmuted. Okay. So what is 2 square?
Ready, sir.
2 square.
I'm ready. I'm ready.
4.
Good. The next question is 14 square. 14 square.
196.
Good. Muting all. Okay. Next one. 4 cube.
64.
Good. Next. 8 square.
16.
8 square.
64.
64. 4 cube, 8 square, same. Okay. 18 square.
324.
Good. 19 square.
729.
19 square.
361.
361. 9 cube. 9 cube.
729.
729.
729.
That's good. That's good. Okay. Next one is 5 square.
25.
I've given you some shortcuts to multiply with 5. I hope you remember. Yes, you do.
Yes.
55 square.
3025.
25.
That was good, Musa Bekar. That was great. Okay, next one. 25 square.
625.
Okay, good. 7 cube.
343.
343. 7 square.
49.
349.
Here is a question for you to answer. From 1 to 20. From 1 to 20. How many prime numbers are there?
8.
From 1 to 20. How many prime numbers are there?
8. 8.
Good. From 61 to 70, how many prime numbers are there?
2.
Good. From 1 to 50, how many prime numbers are there? 4, 4, 2, 2, 3. Remember the code. 4, 4, 2, 2, 3. From 1 to 50,
15.
how many prime
15.
numbers are there?
15.
16,
15.
4, 2, 2, 3. 2 plus 3, 5, 6, 8, 9, 10. So how many?
15.
1, 15. Okay. I heard it as 16. I'm sorry. Just okay. Next one. How many prime numbers are there from 61 to 100?
From
8.
61 to 100.
8.
8,
8.
Yeah.
Yes, 8.
2, 2, 3, 2, 1. From 61 to 100. 60. Okay, 8.
10.
51 to 100.
10.
10. Good. Okay. No worries about the noise. Okay. Fine. Okay. Next one is about rational number. What is a rational number? What is, okay, echo in. What is a rational number?
So a rational number is a number that can be expressed in form of a fraction. Yes.
That's good. What are the types of fraction?
There are 3 types of fractions. There is mixed fraction, there is proper fraction, and improper fraction.
That was great. So next question is, what is the first prime number?
2.
2.
What is the first even number?
1.
2.
1.
Is it 1 an even number?
2.
2. What is the first prime number?
2.
2.
2.
What is the first even number?
1.
Again, why do you say 1? First even number is 2. 1 is an odd number. Yes. The first even number is 2 and the first prime number is 2. Are you clear with that?
Yes, sir.
Yes.
Okay.
Yes.
So 2 is the one and only even prime number. Is that true or false?
That's true.
False.
2 is the one and only even prime number.
It's
2
true.
is the one and only even prime number. Is that true?
True.
Yeah, that's great. Okay, any doubts with the statements which I've asked?
No, sir.
Okay, 91 is a composite number, true or false?
Come again, please.
91, number 91 is number 91 is a composite number, true or false?
True.
True.
Okay, that's great. Okay, 57 is a prime number, true or false?
True.
True.
57 is a prime number, true or false?
False.
False. False.
True. False.
False.
Sir. False.
False. 57 is not a prime number, it's a composite number. Did you get that?
57. No.
Yes, sir.
Number 57 is not a prime number, it is divisible by 3. It's not a prime number. Are you clear with that?
Sir.
Okay, next, just find these numbers are prime number or not. 87, 51, 57 already written, 83, 91, 13, 47, 49. Which other numbers are prime number?
So 13 is a prime number.
Good.
13,
83,
83,
47 are prime number.
47.
7 are prime number. 83, 13, and 47.
47 is
Done. Okay. 87, a prime number. 87, a prime number. No, not a prime number. 51, no. 83, yes. 91, no. 13, yes. 47, yes. 49, no. Are you clear? Are you clear with that? That's great. How to know? It should have only two factors. I'll teach you a shortcut now how to know. If I add two numbers, that should not be divisible by 3. Now 87, what is 8 plus 7? The number 87, what is 8 plus 7? 15. Is it 15? It's 15, Raji. It's 15. Is it 15 divisible by 3? The 15 is divisible by 3. Then the number is divisible by 3. It's not a prime number. Did you get it? Then the 87 is also divisible by 3. 87 is also divisible by 3. Got it? Okay. Now 51. Is that divisible by 3? Is it 51 is divisible by 3? But 91 here is an exceptional case because I'm trying with 13 times 7. That is 91. Did you get that? Yes, you're correct. So the next topic is divisibility rule. Shall we get into divisibility rule? Good, Jim. Jim has identified the topic. Lillian, can you hear me, Lillian? 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 Lillian, can you make it fast? Lillian? Please do save the link. Okay, shall we get into the divisibility rule? Any other doubts? Any doubts? Okay, the first divisibility rule is for divisibility rule of 2. The divisibility rule of 2. How can I find a number will be divisible by 2? Adnan, just check, maybe your typing mistake. Divided by, that's okay, divided by 3. I told you already what is the divisibility rule of 3. Can you make it? What is the divisibility rule of 3? Done? No. What is the divisibility rule of 3? Just imagine about 87, 51, 51, 57. Imagine about these, then you will be able to get it. 87, 51, 57. Yes, the sum of the digits is divisible by 3, then the number is also divisible by 3. Yes, the sum of the digits should be divisible by 3. I hope you remember that. 8 plus 7, 15. If 15 is divisible by 3, then 87 is also divisible by 3. Then sum of the digits is divisible by 3, then the number is also divisible. Sum of the digits should be divisible by 3, then the number is also divisible by 3. Are you clear with that? Are you clear with the rule 3? Are you clear with rule 3? Yes. Now, rule 2, 4, and 8 are same. Okay, rule 2, 4, and 8 are same. Let's say this is rule 2. What is rule 4? In rule 2, last one number should be even or multiples of 2, also 0, are divisible by 2. When I say divisibility rule of 4, last two digits should be divisible by 4, or last number should be 2 zeros, or it should be last two digits should be divisible by 4. Did you get that? Last two numbers should be divisible by 4, or the last two numbers must be zeros. Then the entire number, the whole number given, will be divisible by 4. Are you clear with that? Yes, that's right. Okay. Subrata, can you hear me? Subrata Paul, can you hear me? Yes. You can unmute yourself. Can you unmute yourself? Subrata?
Yes, sir.
Okay. Now what you do, I want you to tell the 4 times table up to 3 digits, starting from 1 digit and up to the first 3 digit. Are you ready?
Yes, sir.
Start. 4 times tables.
Sorry,
Single
sir.
digit. Single
not
digit 4
understand.
times tables means 4. 4 times tables, 4 ones are 4, 4 twos are 8, 4 threes are 12. Understood?
Yes, sir. Yes.
Now tell me 4 times tables up to 3 digit answer. That means 4 times 1 is 1, 4 times 2 is 8. 4 times, you can tell only the answer. 4, 8, 12, 16, 24. Keep telling.
4,
Okay.
8,
Yes.
and 24.
Keep going on. 12, 16, 20, 24. You have to tell all the numbers, should not miss anything. Got it?
Yes.
Start from again from the first. 4. Are you there?
Sir,
Subrata?
face the problem. So
Okay, no problem. See, just keep telling, that's fine. 4, 8, 12. Just 4 times tables answers alone, keep telling.
4, 8,
Okay,
12.
okay. Yes, Peter, you can.
4, 8, 12. 20.
Peter Kunda, you can unmute yourself.
Thanks.
Okay.
Release 4, 8, 16.
Okay.
So it's it's 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72, 76, 80, 84, 88, 92, 96, 100.
Very good. If all these numbers comes in the last digit, it is divisible by 4. That's all. Did you get it? So instead of 4, last digit should be 04, 08, 08, 12, and all the numbers right now, whatever Peter said, up to 100. 100 means last two zeros. 96 and last two zeros. Any of these numbers comes at the last two digits as the same as the 4 times tables. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72, 76, 80, 84, 88, 92, 96, 100. That means two zeros. Anything comes in the last digit, these two numbers together comes in the last digit, or the 4 times table comes in the last digit, then the entire number is divisible by 4. I hope my explanation is clear. It's 4 times tables is being listed. Laban. Okay. Is the divisibility rule of 2, 3, and 4 is clear? Is the divisibility rule of 2, 3, and 4 clear? Okay. Can anyone just give a revision till here? Laban? 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 Can you hear me? You can unmute yourself, Laban. Only you.
Yes, sir.
Right now we are doing divisibility rule. We have done with the prime numbers. So I hope you know what is called prime number, Laban.
Yes.
Can you tell me what is prime number?
The prime number, this is a number that has got two factors, one and itself.
So 91 is a prime number or not?
91. No, it is not.
Why?
It's because 91, wait. Oh, no, it's a number because 91 has got nothing. 91.
It's a prime number?
Yeah, it's a prime number, 91.
Okay, now I'm leaving it to the class. Is it 91 is a prime number? No, 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 no. So many no's are there. 91 is not a prime number because 91 has more than two factors. 91 is divisible by 1, divisible by 91, divisible by 13, and divisible by 7. Are you clear with that, Laban?
So it means, yes, it means it's a composite number.
Very good. Now, can you tell me 4 times tables answers up to 100? For example, 04, 08, 12, 16, 24, 28. Can you try? I left in between 20. Yes. Can you
Sorry?
try? Can you tell me 4 times tables answer?
Come
Up to
again.
100. 4 times tables.
4 times.
Yes. Only the answers. 4 times 1 is 4, 4 times 2 is 8. But you want only the multiples. Yes. Multiples of 4. Only the answers. 4, 8,
Oh, you
12.
mean 4 times 1?
Yeah, only the answers. Yes.
Or the multiples of 4?
Yes.
You mean the multiples of 4? 4 itself. Then 8,
First.
12,
Hmm.
16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72, 76, 80, 84, 88, 92, 96, 100.
Good. So if these numbers comes at the last place, then that number is divisible by 4 tables. Tell me a 3-digit number, Laban.
Sorry,
Tell me a 3-digit number.
344.
Okay. 344. Now, is that the 44 is divisible by 4?
Yes,
Then 344 is also divisible by 4. Clear with that?
yes, clear now.
Okay. Okay. I request you to join the class on time, or it might get delayed for everyone when you have a doubt. Got it?
Oh, sorry, thank you. Okay,
Okay,
sorry.
Laban. Thank you very much. Okay, that's great. Any doubts still here? Okay, right now we have done for divisibility of 2, where the last 1 digit should be divisible by 2, or 2, 4, 8, 6, or even number 2, 4, 8, 6, or 0. Divisibility of 3, we have seen that means sum of the digits should be divisible by 3, or when I add the numbers, for example, 369, or any number bigger than that, when I add the numbers and if they are divisible by 3, 9, 10, 11, 12, 18, 18 is divisible by 3, then 369 is also divisible by 3. Did you get it? If sum of the digits is divisible, 3 plus 6 plus 9 is 18. If that is divisible by 3, then 369 is also divisible by 3. Okay. Now, the last we saw about divisibility rule of 4. That means 4 multiples at the last place. If it's a single digit, it should be a 04 or 08. And rather than that, it can have even 2 zeros at the last place to say that the number is divisible by 4. Apart from that, the multiples of 2 digits like 12, 16, 20, and goes on. All these numbers comes at the last place when the whole number is divisible by 4. For example, as we have taken, Laban has said 344. If 44 is divisible by 11, that 4, and you get the answer as 11. So 44 is divisible by 4, then 344 is divisible by 4. Are you clear with that? Clear with that? Yes. Next one about divisibility of 8s. Tell me what is the divisibility of 8s? Divisibility of 8s. We'll go on with the next. We'll go with the next. Divisibility of 8. So for the divisibility of 2, last 1 digit. Divisibility of 4, last 2 digits should be divisible by 4. Divisibility of 8, no sum. Last 3 digits should be divisible by 8. Either as 0, 0, 8. Let's say 9008. Is it divisible by 8? 008 is divisible by 8. So 9008 is also divisible by 8. Are you clear with that? Yes. Now, let's say that 216 is it divisible by 8? Is it 216 is divisible by 8? Yes, below it, careful before you answer. 216 is divisible by 8. Then 9216. Is it also divisible by 8? Yes, 216 is divisible by 8 for sure. 216 will be divisible by 8 for sure. If 216 is divisible by 8, is that 9216 is also divisible by 8 or not? One 152. Okay, let's check it. This 152 is divisible by 8th table. The 1152 is also divisible by. That's okay, brother. Then that is also divisible by 8. If 152 is divisible by 8, 1152 will also be divisible by 8. You clear with that? How is the divisibility rule? Yes. Peter, which rule is not clear to you? Can you let me know, Peter? Peter, which rule is not clear to you? Eight. You can unmute yourself, Peter. You can unmute yourself.
Yes,
Okay.
sir.
Tell me a 3-digit number which is divisible by 8.
We'll go for 216.
Okay. Is it 216 is divisible by 8?
Yes, 216 is divisible by 8.
Then in front of that number of 216, how much ever number I write, it doesn't matter. The complete number is divisible by 8. The number can be how big it is, doesn't matter at all. Just to find, will that number be divisible by 8? Yes, it will be divisible by 8 because the last 3 numbers are divisible by 8. Then the big number will be divisible by 8.
Okay, now clear, sir.
Okay, Peter, that's great. And anybody else have doubts? Anybody else have doubts? Anybody else? Anybody else? No doubts. Okay. Now, the next one is Liban, is that the number to calculate the divisibility rule? That's too big, but it is divisible by 2. 3 table. No, it is not divisible by. Yeah, it is divisible by 3. No, not divisible by 3. And it is not divisible by 8. And also not divisible by 4. It's a phone number, but I expect that not to do it in the class hours. So that phone number of him, only the number is divisible by 2. It's not even divisible by 3, 4, and 8. I hope you remember the divisibility rule better from now. Okay. Next one is for the rule of 5. Can anyone tell me what would be the rule 5? Divisibility rule of 5. The last number should be 5 or 0. Yes. Now let's talk about the divisibility rule of 25. It's needed in some places you have to calculate it faster. So divisibility rule of 25. When can I say a number is divisible by 25? It would help you out. Yeah, I got it, Vivian. When is a number divisible by 25? Yes. So numbers ending with no, only 25, 50, 50, 75, and 00 will be divisible by 25. Rather than this, any numbers you get 15 or 35 or 45 or 55 will not be divisible by 25. Are you clear with that? those are divisible by 5. Yes, Axman. 0, 5, 0, 5, 0, 5, 0, 5. The last number should be these things so that it's divisible by 5. But the last number of 25th table is only 25, 50, 75, 00, 25, 50, 75, 00. Did you get it, Axman? Did you get it? Okay. Shall we go on with the next? Divisibility rule of 9. For the divisibility rule of 3, sum of the digits divisible by 3. Then the divisibility rule of 9, what it would be? Divisibility rule of 3, the sum of the digits should be divisible by 3. And the divisibility rule of 9, the sum of the digits should be divisible by 9. Yes, beloved, your answer is right. So the sum of the number should be divisible by 9. Okay. Anyone who is not clear with the statement, let me know. If anyone not clear with the statement, let me know. Laban. Okay. Laban, Zawan, or Daniel. Anyone can unmute. Laban, Zawan, or Daniel. Anyone can unmute yourself.
Sir.
Okay,
Yes, sir.
thank
Laban.
you.
Yeah. So I've unmuted myself.
Thank you. Tell me a 3-digit number. If you add, it should be divisible by 9. Tell me a 3-digit number. If you add, it should be divisible by 9. That means
Okay.
the sum of it should give you in 9 multiples.
423.
4, 2, 3. What is 4 plus 2 plus 3?
9.
Then 423 is also divisible by 9. Did you get it?
Yes.
Now give me a 4-digit number. If you add, it should give you either 9 or 18 or 27.
Well, when we add the 3 digits,
Now I've given you a 4-digit number. When you add the 4 digits, you should get the answer in the multiples of 9.
okay. What 1423.
1423. Okay. If you add them, do you get what do you get?
Ten.
Is it 10 is divisible by 9?
No.
Then that number
Okay.
is not divisible by 9.
1332.
I'm
Okay.
sorry?
What about 1332?
1300
32.
332. 3, 6, 7, 8, 9. Yes. If I add, I get 9, then it is divisible by 9.
Okay.
So now I can have some big numbers like, why don't you try like this? 5724. What's 5 plus 7 plus 2 plus 4?
That's 18.
Is that 18 is divisible by 9?
Yes, it will give us 2. Yes, it's divisible.
Then 5724 is also divisible by 9.
Zero.
Five, 7, 2, 4 is 18. The sum is 18. The 18 is divisible by 9. Then 5724 is also divisible by 9. Are you clear with that? Others, are you clear with that? Okay, Zuban, that was a good count. 10782. 1 plus 7 plus 8 plus 2. How much do you get? 10782. Oh, Edwin. 10, 17 plus 1, 18. Yes, that number is divisible, Zuban. Because the sum of the digit is 18, then the whole number is divisible by 9. Yes, there is a rule for 7. I'll give you. There is a rule for 7. Okay. Till here, any doubts? That's fine, Zovan. Divisibility of 2, 3, 4, 8, 9, 5. We have done. Any doubts? No doubts. Okay. Any doubts, anyone? Can I clear the screen and get into the next one? Okay. The next one is rule of 6. 3, 5, 8, 4, 8 plus 8, 16, 16 plus 4 is 20, 27. Yes. Kurumfashi Jackson, that's right. Kurumfashi Jackson, your answer is right. It is divisible by 9. Thank you, Vivian. Okay, next one, 6 times tables. That means divisibility of 6. Yes, or I can call it as multiples of 3 even number and even. Multiples of 3 even number. They will be divisible by 6. Multiples of 3 and it should be even number. They would be divisible by 6. Yes. 561, no. It's an odd number. Odd numbers will not be divisible by 6. It should be an even number and also divisible by 3. Even number divisible by 3 or divisible by 6. I hope it is clear now. Multiples of 3 even number. Yeah. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72, 78, 78, 79, 80, 84, 84, 90, 96, 96, 102, goes on. Even number which are divisible by 3 are divisible by 6. Any doubts with divisibility of 6? That's good, Amrachi. I can see some response from you now. Zwan, is that an even number? 376497, is it an even number? Zwan, 376497, is it even number? Yes, 96 is divisible, yes. Zwan, the number which you have given, is it even number? No, then that is not divisible by 6. So not an even number, not divisible by 6. 24, 42, yes, they are. Yes, 36 is even number and also divisible. Yeah, shall we go with the next one? Okay. So the next one is divisibility rule of 10. Very easy. Rule of 10. How to say the number is divisible by 10? Yes, the last digit should be 0. That's all. Okay. Ends with 0. Yes, that's very small. Rule of 11. We'll come for the other numbers. Before that, we'll finish it. Rule of 11. Good, Smith. Good effort. Rule of 11. Now, last number 1. Okay, then 31. Last number 1. Is it divisible by 11? Same numbers. Okay. So 2, 2, 2. Same number. Is that divisible by 11? No, it's okay. It's a learning time. 2, 2, 2 is same number. Is that divisible by 11? No. Okay. 11, I'll tell you how to do it. Keenly listen, then that becomes very easy. Okay, are you ready? It has a process to remember, but still you can. Are you ready? Okay, I'm going to take the number as I hope you know what is 11 square. What is 11 square? What is 11 square? 121. Yes. So look here carefully. Fine, I explained, but that's not the exact rule. One, the first number, second number, third digit. First digit, second digit, and third digit. So let's say that we are taking the first digit and the third digit alone. Are you clear with that? Taking the first digit and the third digit, that means one left out the other. And we have to add it. Now, what is the sum of the first digit and the third digit? What is the sum of the first digit and the third digit? Two. And I have the middle digit. The second digit should be subtracted with this 2 so that I should get either 0 or 11. For this, I'm getting 0, so it is divisible by 11. Or I should get 11. When I do like this, then that will be divisible by 11. Are you getting it? Are you getting it? So odd places like was first place. Yes, it's exactly below it. Okay, may I know your doubt below it? You can unmute yourself. Bodily below it. You can unmute yourself. Beloved. Beloved.
Yes, sir.
Yeah. What was your doubt?
And please, could you explain it again?
Okay. Give me a 3-digit number, beloved.
Okay. 323.
Okay. So in this, which number is the first? You can take on the right or left, anything. First number.
3.
So I'm taking, let's say, from the left side. This is called first place. This is second, and this is third. That means odd places. Did you get it?
Yes, sir.
Odd places should be added and subtracted with the even places. Same thing, even if I have one more digit in the even places, odd places should be added and even places should be added and both should be subtracted. Did you get it?
Oh, okay.
Okay, now 3 plus 3 is 6. 6 minus 2. What is 6 minus 2?
4.
I should get 0 or 11. If I get any other answer, then the number is not divisible by 11.
Oh, okay.
So 323 is not divisible by 11. Now I want you to give a 5-digit number.
All right, 5-digit numbers. 1 7 3 6 2.
17362. Am I correct?
Yes, sir.
Okay, just a minute. I'll just write it. 1 7 3 6 2. Now this is the question of beloved. I'm coloring it in blue or a green. So odd places are 1, 3, and 2.
Yes, sir.
Okay, add them. How much do you get?
6.
Okay, 6. The odd places are subtracted with even places. What is 7 plus 6?
13.
13 minus 6. Does it give you 0 or 11?
No, sir.
Then this number is not divisible by 11.
Okay.
Okay, now let's make this number divisible by 11. By adding what, I can make this number divisible by 11.
5.
Okay, if you add 5, what it happens? 3, 4, 5, 6, 6 plus 5 is 11.
Yes, sir.
I think you have to add 7. Let's say this number is not 2 anymore. This is 9. Okay,
Okay.
so 9 plus 3 plus 1, how much?
That's 13.
13. And 7 and 6 even places. 7 and 6, how much?
11.
13.
13, yeah.
So 13 minus 13,
0.
then that number 17369 is divisible by 11.
Oh, okay, sir.
Are you clear with the steps?
Yes, sir. Yes, I get it now. Thank you, sir.
Okay, then. Okay. We'll come for 7, Vivian. I want you all to be clear till here. 11, any doubts? 11, any doubts? 11, any doubts? Six. 11. 11, can you quickly type with 3 multiples numbers? Make it quick. 3 multiple numbers, type it. Type it fast, 11. 3 multiples, 3, 6, 9, 12, 15, 18, 21, 24, 20. Yeah, make it fast. No, type everything. It's okay. No, 11, all the numbers, 3 multiples, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42. You have to type everything as much as you can. Only the 3 multiples. I hope Laban is typing. Fast, fast, fast. Make it fast. Make it fast. Make it fast. Make it fast. It's fine. Whatever you have typed, you can post it. Good. All these even numbers are in the tables of 3. Is that true or false? Then they are divisible by 6. Did you get it? Even number multiples of 3 are divisible by 6. Even numbers of divisible multiples of 3. Even numbers of multiples of 3 are divisible by 6. Is that clear? Okay. 90 is an even number. Yeah, I'm clearing it. If you have done till here, you can take a screenshot of it. I'm going to clear the frame and go do with 7, 13, 17, 19 tables. So for that, one more 12 table, we will do that also. But before that, I want you to learn it till here so that I can clear the frame. Make it fast. Make it fast. Okay, can I clear the frame? Can I clear the frame? Can I clear the frame? Yes. See the notes. You will get it in the YouTube. I would not say no, but if you wanted to have it in your hand, clear it. These are all my notes, whatever I'm making you to understand. This is what I have understood and I'm teaching you. So I don't refer any books. The way I understand the topic, the way I teach you. I could say, yes, the method is being followed everywhere in all the math books, but the way of explaining to you that how do I understand the topic, in that way I'm trying to explain you. So this is the notes of 2, 3, 4, 8, 9, and nothing doing with 5 and 10, so you can leave it. 11 and 6. Yes, we will start on with 7 times 7 divisibility, no worries. I'm going to clear it. 1, 2, 3, go on. I don't know whether we can retrieve it. It's done. Are you ready? Okay. 7 divisibility. I will take 2 examples and do it. One is with the number which you already know, 49. The other number also which you already know, 343. Okay. Now let's prove that these numbers are divisible by the number given. Okay with that? Okay. Now 4 and 7. What is the last digit of 49? What is the last digit of 49? What is the last digit of 49? Nine. That I'm see very clearly, listen it, don't miss it. If you don't understand, you will skip everything. The last digit is multiplied with the number, so that is 2. The last digit is multiplied with the number that is 2. So all the numbers of 7 divisibility, the last digit will be multiplied with the 2. So 9 times 2 is 18. And then it is subtracted with this form. 18 minus 4. So 18 minus 4. Rest of the number, this is called rest of the number. I have to subtract it. If I subtract, what do I get? I have to subtract with the number what I've got over here. 9 times 2 was 18. Take the last number, multiply with the 2. Whatever answer you get, subtract it with the rest of the numbers from here. So over here you get 14. Over here what you get? 34 minus 6. 3 is multiplied with 2, it's 6. Rest of the number means that is 34. 34 minus 6 is 28. Is that so? Yes. Now let's count for 49. I'm explaining again with 49, then with 343 simultaneously, so you'll understand better. 9 times 2 is 18. Rest of the number is 4. Subtracted with that, so I get 14. So that means if that 14 is divisible by 7, the whole number is divisible by 7. Else we can keep doing again. 14, take it up. Last digit is multiplied into 2. Last digit is multiplied into 2. We get 8. Rest of the number is 1. I subtract with that, so I get 7. Then the number is divisible by 7. I can stop it in between. There is no need to do it up to the end. Did you get that? Did you get that? 343 times 2. So 34 minus 6 is going to be 28. The 28 is divisible by 7. Then 343 is also divisible by 7. No, it is not needed till the end. It is not needed to till the end. Either you get 0 or 7 at the end. It is not needed till there. You can stop in between. I know 14 is divisible by 7. That means 49 is divisible by 7. I know 28 is divisible by 7. That means 343 is divisible by 7. I can stop it in between. If I don't know, I can keep going. If I still don't know 28 is divisible, then I can make it. Okay, 8 times 2 is 16. The rest is subtracted with 2. Again, I get 14. So once you start with that, then whatever number you get, it will be divisible by 7 only. Did you get that? Anybody did not understand? Let me know. I'll explain it again, or let's go on with the next. Yes, it's possible. Nothing wrong. I cannot subtract it with 7. Jean Baptist, are you asking 36 is divisible by 7? Subtracting 3 times 2 is 6, right? That is being subtracted with this number 34. Clear with that? Yeah, you can do it as negative answer, doesn't matter at all. If this is minus and this is plus, doesn't matter. It is divisible, that's it. Our work is to find whether it is divisible. Even though you get it in positive or negative, it doesn't matter at all. That's why I have not taken it. Are you clear with that? Yes, Vivian, clear with that? Yeah, I don't want to take the negative number. However, it is divisible. Only that you need to prove it. That's the reason I'm not considering it. Jackson, what's the last number of 343? That doesn't matter with the negative number. 343, what is the last number, Jackson? 343. What is the last number, Jackson? 3. With the last number, what I should multiply to find whether it is divisible by 7? With the last number, what I should multiply, Jackson? With the last number, what I should multiply? The last number, what I should multiply? 2, not E2. Yes. What is 3 times 2? 6. Yes. Now, in that 343, I have taken the last number. What is the rest of the number? In 343, I have taken 3. What is the rest of the number? $34. I have to subtract that. 34 over here. 34 to be subtracted. 34 minus 6. 34 minus 6. (34 minus 6). How much, Jackson? 28. Is that 28 is divisible by? Is that 28 is divisible by 7? Is that 28 is divisible by 7? Is that the 28 is divisible by 7? Yes. Then 343 is also divisible by 7. That's all. Okay, what was the question? 4, 6, 7, 8. Okay, look here. I'm taking a different color. So 4, 6, 7, 8 was a doubt of MAT 4, 6, 7, 8. 8 is multiplied with 2. Okay, I'm taking the 8, multiplying it into 2. That's 16. The answer 16 is subtracted over here. 7 minus 6 is 1. 6 minus 1 is 5. And this is 4. And again, 1 is multiplied with 2. 1 times 2 is 2. So I'm subtracting 45 minus 2 over here. I get 43. That is not divisible by 7. So 4, 6, 7, 8 is not divisible by 7. Did you get that? 4, 6, 7, 8. Last digit is multiplied into 2. You get 16. Subtracted. You get 451. And multiply again with the last digit with 2. You get a number. Subtracted. You're not able to do, or you're not getting up to the 7 times table, not reaching it up, the expected tables, that is 7 times tables, or you have to get 0. No, then the number is not divisible by 7. Is that clear? Yes, Lavan. Oh, Lavan has done the question. Good. Nice to see Lavan. Lavan understood the concept better. Good. Okay. Next, any other doubts? Any other doubts? No? Okay. Can I clear the frame? Yes, Robert. May I know your doubt? Yes, Robert Muzamila. Robert Muzamila, may I know your doubt? Divisibility rule. To find which number would divide them and what. So this topic right now is divisibility of 7. Divisibility rule. It's about divisibility rule. Now, see divisibility rule of, yeah, you can call it yes. 7 last digit to be multiplied with 2, rest of the number to be added or subtracted. Oh, sorry, last digit to be multiplied with a number. Okay, so for the 7, I'm going to multiply it with 2 and subtract. Okay, if I'm doing that for 13, I have to multiply with the number and it should be either added or subtracted so that I can find. The same rule for 17, 19, any prime number, same rule. Seven, can you hear me now? 7. I have to either with the 17 multiply a number, add or subtract so that any prime number, take up the last digit, multiply it with any number. For 7 it is 2, for 3 it would be different, for 17 it would be different, for 19 it would be different. Okay, you will multiply the last digit with the number, rest of the number either to be added or subtracted. Did you get it? Last digit to be multiplied with the number, let's say that random number 451. Okay, this 1 is multiplied with the number n. Whatever answer you get, 1n, that should be subtracted with this 45 or added with the 45 so that what number are you trying, whether it is divisible, you have to get that answer. That's your homework. That's your homework. Okay, you're gonna find out for 13 what I should multiply and then add or subtract. 17 what I should multiply, add or subtract so that you can use 13 itself. 13 multiplied by a number, 13 multiplied by a number, you get an answer. That means the last digit 3 is multiplied with the number and added with the rest of the number so that again you might get 13 or multiples of 13. Did you get it? Or 17, you can take the same number, multiply some number with that 3, either you add or subtract with the rest of the number so that you get the multiples of 3 or you get 13 itself. I'm sorry, either you get the multiples of 13 or 13 itself. Like this, you're going to find for the rule of all these. Did you get that? It's so easy. It's so easy. You need to find, you have to spend some time. You have to spend some time for 5 minutes. You might be able to get it. Okay, fine. Thanks for the day. Have a great day. Tomorrow, let's continue from the same topic. Yes, it's possible for all the prime numbers. It's possible for all the prime numbers. It's possible for all the prime numbers. Yeah, no. But for your exam cases, it's enough up to 23. The prime number is sufficient. You get that? Please do listen to the video for 2 to 3 times, Robert. I would suggest you to do that. Okay. Thank you very much. Any other questions? Thank you all. Thank you very much. Have a great day and let's catch up tomorrow. Thank you. Assignment. Finding the divisibility rule for yourself for 13, 17 and 19. And we'll tomorrow again discuss with that. For divisibility rule of 13, 17 and 19, you're going to find it as we did it for 7. Okay, welcome. Thank you, Doc. Bye-bye. Thank you all. Thank you, Vivian. Thank you, Chinin. Thank you. Thank you, Subrat. Thank you, Iruma Patience. Thank you, Lesango. Thank you all. Tanishriya, thank you.